Welcome to the ProCAncer platform. The purpose of this video is to guide you through the whole process of uploading, annotating, curating, and preparing the appropriate cohort populations to be used for AI model development. I will start our demo presentation by focusing on the three main domain-specific areas of functionality of the platform. The first one refers to the data providers, who use all the infrastructure to upload clinical and imaging datasets according to the project's guidelines and best practices. The second one refers to radiologists or other nominated individuals that use the platform's data curation tools to annotate and curate the imaging data. And finally, the third one refers to AI experts who can search the available metadata in order to create the appropriate cohort populations for developing AI models. First, we will focus on the data provider user role and demonstrate all the steps that need to be executed in order to upload data into the platform. The initial step is to collect the multiparametric MRIs and related clinical data according to the protocol agreed upon. Then, the data provider should perform the first level of anonymization with a software tool of his preference and save the anonymized imaging data on the local hospital premises. If this is the first time the user accesses the platform, he has to be registered to the ProCAncer identity provider and wait for authorization. Once this is completed, and after he has received the data upload tool, he can then proceed to the upload process. So, let's now see everything in practice by using the following real case scenario. Let's suppose we have a patient who is 79 years old with a high PSA value and a negative digital rectal examination that was sent by the urologist to perform an MRI. The MRI revealed a Pirates 4 lesion with a maximum diameter of 10 mm in the right peripheral zone, basal posterolateral. The patient underwent biopsy, and because of positive findings, he was referred to perform a prostatectomy. The results of the prostatectomy revealed a 4+3 Gleason score lesion extended beyond the prostate gland of an overall volume of 0.61 cc, where biochemical relapse was diagnosed some months later. Now, once the data provider has collected the imaging data corresponding to this patient and performed the first level of anonymization, he can proceed with the process of uploading data into the platform. The user opens the upload tool and clicks on the DICOM Add button. He then selects the imaging data folder to be uploaded and clicks on the second step of DICOM anonymization. There is a message showing that the anonymization is in progress, and once the anonymization is completed, the user proceeds to edit the form. Let's suppose that the user has doubts on which form this patient belongs to. He can go back to the ProstateNet platform and access the dedicated Help Center area where he can consult the use case decision flowchart. By following this chart, the patient falls into the form 1 + 2 + 5 + 9. Going back to the upload tool, the user is ready to fill up the form fields. Once the user has completed the form, he clicks on the Save button and proceeds to step 4 to upload the DICOM images into the DICOM store. Once the DICOM files have been successfully uploaded, there is a message on the bottom left corner. Finally, he clicks the 5th button to upload the clinical data into the metadata repository. Then, responsible radiologists or other nominated individuals from each clinical site can select the image series to be segmented using the platform's annotation and curation tools. First, they log into the ProstateNet web interface and visit the DICOM browser area, which is the access point for their uploaded, as we say, staged data. We need to point out that the staging area is private and protected. This means that users have access only to the data uploaded from their home organizations. By using this browser, the users are able to review and verify the correctness of the uploaded images and select the ones for which they will subsequently create segmentation masks. Let's select one study to perform the curation and annotation tasks. By clicking on the series icon, the user is able to see the list of available series for a certain patient.
Once you have selected the study you wish to curate, click the A icon in order to launch Advantage Curation tool. The tool will list all the series found in the study. Use the eye icon on the left-hand side in order to preview any of the existing series. Before you start the curation process, make sure that you have selected the static series for the co-registration part. That should usually be the axial T2 weighted series. Use the buttons on the right-hand side to start the curation process. The buttons are color-coded. A grayed out button means that a step cannot be executed until the previous step has been completed. An orange button means that the step is pending, while a green button means that the step has been completed. Let's curate the DWI series. Click on Motion Correct. Then click Run to start the motion correction. You can view the results in two side-by-side viewers. On the left-hand side, you can check for inter-volume motion, while on the right-hand side, you can scroll through all the slices of all the volumes of the DWI series. If you are happy with the result, click on Approve in order to store it on the cloud staging area. Once the new series has been uploaded, you will be redirected to the co-registration app, taking as input the previously selected T2 series and the motion-corrected DWI. Click on Run again to co-register the DWI series to the T2 weighted series. Check the result. In this case, the co-registration has failed. Click on Advanced Settings and tweak the hyperparameters of the registration algorithm. Click Run again. Check the result. Use the opacity sliders on the left-hand side in order to improve visualization. If you're happy with the result, click Approve in order to store it on the cloud staging area. Once the new series has been uploaded, you will be redirected back to the series list. You can continue curating any of the remaining series.
Once we have our study uploaded to the platform, we can open the annotation environment. For that, we have to select the T2 weighted axial MR series, and then we can open the annotation tool. The annotation tool will be open in a new window where we can visualize the MR series that we have uploaded. The annotation is going to be performed in two main steps. The first step is to segment the prostate, in which we are going to divide the prostate in three main areas, which are the transitional and central zone, the peripheral zone, and the seminal vesicles. And then we are going to perform the annotation of the lesion. So by default, we have added three main lesions, and then we will see how we can create new ones in case this is necessary. So the first step will be to perform the segmentation of the prostate. For that, we have incorporated in the annotation environment automatic tool in order to perform this analysis or this segmentation in an automatic manner. This is a method based on convolutional neural networks that runs in the background and provides the output once the segmentation has been performed. In some seconds, the process has finished and we can visualize the annotation in the viewer. Now we can see that the annotation has been loaded, so we can find here in the left bar of the series, in the part of the annotation, we can find the new seg file that corresponds to the segmentation of the prostate. So if we click it, we can load the segmentation and we can visualize how the automatic tool has performed this automatic segmentation. If we find any issue in the segmentation, we can use the tools that we have in the annotation environment to perform its correction. For example, if we want to perform the correction here of the peripheral zone, we first have to select the peripheral zone, and then we can select the brush tool, and we can start performing the corrections. We can decrease, for example, the opacity to see it better, and we can delete some regions, or we can add them to the annotation. Once the annotation has been corrected, we have to store a new file. So for that, we can click the Save button, and we can say that this is the segmentation of the prostate. Then we click on Save, and it will be stored in the database. Finally, we have to perform the segmentation of the lesions. For that, we have to reinitialize the viewer. And in this case, we are going to open a new, we are going to use the other labels, the ones for the lesion. Here we have a lesion. So for that, we have to select, for example, the first lesion, then again the brush tool, and perform the segmentation manually in this case. So we can go slice by slice, performing the segmentation of the lesion. So in this case, I'm going to segment that part and also this part, and then I have finished the lesion segmentation. As we said previously, we can create new lesions in case there are more than 3 in the prostate. So for that, we can click here in new label, select a new color, for example, this one more purple, and then in this case, we will have this new lesion for created. However, in this case, we only have 1 lesion, so we will perform the storing of this new segmentation. So we click here, and now in this case, we have lesions. So we click on Save, and finally we have everything stored. So with the annotation of these 2 regions, the prostate and the lesion, we have finished the annotation, and we can find the 2 new seg files that we will need to push to the final repository. If we go to the portal, we can also see that the new seg files have been stored.
Now, let's proceed to the metadata catalog and focus on the AI expert user role. First of all, the user is able to explore the metadata of all the cases that have been uploaded to the platform. Here, a user is able to view patients' clinical information along with their imaging series metadata. First, let's limit the cases per page for better viewing of the data. The user can additionally slice and dice the information by using the filtering functionality of the tool. For example, a user is able to find all the patients that belong to use case 2 with acinar adenocarcinoma and have imaging series from a Siemens scanner. They can also sort specific columns of interest by clicking on the column name, as well as expand the columns to see multi-valued attributes. Finally, they can select which attributes to view in the main metadata window area. If the user wants to explore just the imaging series metadata, he can select the imaging series submenu, or explore the metadata that correspond to segmentation tasks, such as who did the segmentation, when, and the labels that the images were annotated with. Whereas, for the curation task, the user can also explore some algorithmic parameters used for the curation outcome. Finally, there is a data upload monitoring page where users can view the current statistics of the upload process, including the number of patients that have been uploaded into the platform, the number of use case instances to be used for AI model development, as well as other interesting metrics. Now, let's see how an AI expert is able to download filtered data into a CSV file.
ProstateNet is not just a medical imaging repository, but also provides the tools and the infrastructure for a machine learning and AI expert to perform data analysis, exploration, and AI model development. In a typical workflow for the development of an AI model that we present here, a A data scientist prepares a data set by exploiting the filtering capabilities of ProStateNet metadata catalog and exports the list of the identified icon series. The selected cases are then uploaded to the AI Vault, which is the development environment for the platform for building and training machine learning models, and then deploying them in production. In the development environment, filtering and refinement of the initial dataset are performed, followed by some exploration using the clinical variables of interest. Next step is the retrieval of the associated imaging data from the DICOM image repository and the transformation of those images to NIfTI format. NIfTI format is more appropriate for the downstream analysis. The data scientist can now run image processing tools like N4 bias filter and visualize the results. Provenance information is automatically saved on the MLflow platform that is integrated with the ProStateNet in order to provide relevant metadata and documentation about the experiment performed. So, starting the demonstration, the model developer will visit the metadata catalog and get information about the available imaging series together with the associated clinical information of the relevant patients. Here, a number of filters are available. And let's say that the model is interested on the data of use case 2, so she specifies the relevant filter. She also specifies additional relevant information, for example, information about the series and the image segmentations, if that information is available. And then she or he can press the download button, selecting the attribute names and the CSV format in order to download the relevant data to the local workstation. The user then visits the ProStateNet portal and presses the AI Vault menu item, and then the development environment of ProStateNet for the development of the AI models is loaded. This is a notebook-based development environment that will be familiar to any data scientist. By clicking the upload button here, we upload the data that we just downloaded. And then we can start working on our notebook that contains scripting code together with the results of the code when executed. So we first load the dedicated Python library offered by ProStateNet technical team that allows download and direct access to the DICOM server that hosts the DICOM images. The next step is to load the data that we have just uploaded. So we take the path, the data, and we load the CSV that we just uploaded. We can inspect the contents of this comma-separated values file, and we can then filter in order to get the subset of the imaging series, the ones that are T2 weighted for the cases that participate in use case 2. The development environment supports most of the common libraries for data exploration, which is a kind of mandatory step prior to the AI modeling. And here we can see, for example, the creation of a box plot of Gleason scores and also a scatter plot of some relevant clinical variables. Now, the user is able to get access to the actual images by downloading those images from the DICOM server to the development environment. After this download, the user is able to inspect those images, for example, one series that we show here, to see the actual slices contained in this series. Since the preferable format for the AI modeling is NIfTI, now the user can easily convert the DICOM series and store them in his private space by invoking another code that we have prepared in order to do this transformation to NIfTI format. Then the pre-processing tools can run, and we have developed an optimized version of the N4 bias filter, which is available as a Docker image that the user is able to invoke and run, as we see here. So now we see that the N4 bias filter has finished. A new nifty file was created. We can see the results of the filter by comparing the one slice of the original image with corresponding slice on the bias filtered image. And here we see the difference between the two.